Assalamu alaikum. Welcome to Turkish Engineering. We have a watermelon seed, and this plant grows with different rates in different years based on the mean temperature difference between these years. So we have two critical data. One is the time, okay, growing days, we have the time, and we have the temperature. We can convert the time to speed by just taking 1 over time, okay? 1 over time, just the speed rate, okay? We can get 1 over 87, 1 over 85, and like this, okay? So we have idea to how to convert this time to speed, because we will work with reaction speed. As you remember, that was a function of time, and it is e to the power minus activation energy over RT, okay? We will use the same idea here. So if you remember, in order to get activation energy from a plot, we were doing ln k. We take ln of both sides. So we have EA over R times 1 over T. We separate the variable here. Okay, we have temperature which is varying by time, by years. So here we want to calculate this slope. We take derivative of ln k. That means that will be in the y-axis, and the second variable, which is 1 over t. So we should take data as 1 over t, not temperature, okay? 1 over temperature. That will give us the slope which corresponds to this value, and from that we can get the activation energy, because this is a constant value, ideal gas constant. So let's start plotting this data set into Excel and find what we need. Okay, here it's not important for us. Okay, we need speed, which is 1 over time, or we can plot a couple of things. Let's say T, capital T, 1 over T, which is speed. Okay, then we have 1 over capital temperature also, and we have ln k, but we don't know k. Okay, ln k, that will be ln 1 over t, because that speed is just given as, we don't know speed, we have time. 1 over time will give us the k. So ln 1 over t is just our ln k, okay? This is the k, speed. Then we have 1 over capital T, 1 over temperature. Okay, let's start plugging the values in. So you have time, different days, okay? So you can realize something here. Growing days decreases, okay? Time decreases, time that I need to grow this plant, when I increase the temperature. But that's what we know, right? When temperature increases, reaction rate will increase. And that also, we have a couple of reactions in the plants, some biochemical reactions. So we can also represent the activation energy in terms of temperature differences, how it affects the speed of the growth. Okay, we create an analogy between two fields in order to understand the reaction rate more. So here the temperatures, we will use the mean temperatures. And here you have 1 over this value. You can also copy to here. When you copy paste, that will give you 1 over temperature. And you take ln of 1 over t column, which is this one. Then we have 1 over t. Oh, we already calculated 1 over t, okay? So let's get the plot. If you remember, the x-axis will be 1 over t. Okay, this is the x-axis. And this is the y-axis. Slope will give us the result. Let's create a plot. Insert our data set. X values are here. Y values are here. The plot will not directly give us the slope, we need another step to do that. Here you can add the regression. You can say it's linear or exponential or logarithmic. We need linear, okay, because we need a slope here and the distribution is quite linear. Here a further step that we have a mistake here, that we did not convert the temperature to convert to Kelvin. Okay, so let's do that. This value, let's change it to other column. Now we have the correct result, because we should get it as a function of, like as a unit of Kelvin. Okay, so let's check again. You have 1 over temperature, and this is, we took it from the Kelvin, and you have ln speed. That's what we need. And activation energy, now it's a different value. We can get that value and plug in here. We will just change. I made that mistake, but now we will have different activation energy because of, like, using Kelvin, using Celsius will lead to a mistake, but we can correct it here. So we will get 28.2 kilojoule per mole as a result. Thank you for watching.